Until now we have seen how to do protocol analysis and packet analysis. Now, what we will try to do is learn about flow analysis and then how to do higher level protocol analysis. There are a lot of tools that are available to do higher level protocol analysis. So, I mean if you go to Kali Linux, okay, for specific protocols they have provided analyzers. So, once you get the data packets, then you can run these tools to analyze what happens with those protocols. First, let us talk about definition of a flow analysis. Okay, it is an examination of sequence of related packets. So, that is called as a flow. Okay, flow analysis you can also call it as, sometimes it is they call it also as stream analysis. In fact, Wireshark uses the word TCP stream. A flow analysis is typically conducted in order to identify traffic patterns and then isolate suspicious activity and analyze higher layer protocols or extract data. So, if a flow is actually defined in RFC 3679, okay, it is a sequence of packets sent from a particular source to a particular unicast, anycast or multicast destination that the source desires to label as a flow. A flow could consist of all packets in a specific transport connection or a media stream. However, a flow is not necessarily 1:1 mapped to transport connection. So, the ideal, I mean these are all very formal definitions. So, what we understand is that we have something known as a session. Okay. A session is established between two endpoints for some sort of communication. All the packets that ensure that the session is taken care correctly, you can call it as a flow. Okay. For example, I open FTP connection to a particular server. Now, you actually this establishes a session to a particular server. So, all the packets that I use to transfer my file through FTP to the other server, including the acknowledgements that I receive, if there is any, usually UDP does not send any acknowledgement, but if there is any, then I would like to term that as a flow. Okay. Now, actually we can use Wireshark to do this flow analysis. The easiest way is to just go to analyze and then if you look at follow TCP stream, essentially TCP establishes some kind of session. So, this can actually go ahead and get what is happens with that particular TCP flow. So, it is much easier. There are other tools that you can look at. The first one, as we know, is equivalent to Wireshark as T-Shark. Then you can have a tool called TCP flow, okay, or PCapCat. Okay. So, PCapCat, the installation is slightly more complicated, okay, or you can use TCP extract, okay, and almost all these tools you can just use to identify the more or less, I mean some feature is available in certain tools, some is not available. So, you can actually do a comparative study of what T-Shark has and what TCP flow has, what TCP extract has, and so on. Essentially, it is a good idea to know a lot of these tools, so that your work jobs automating these your work becomes much more easier. Okay. So, how do we do flow analysis? One is we just list the conversations and flows, and then the particular flow of interest that we have, we just export it, and then using that we try to identify, okay, that whatever we have exported, you try to identify what is the data that is of relevance to us during network forensics. Do not worry about many of these items being vague. We will actually be doing a case study after this module. So, there we will try to correlate what we have learned and then along with the case study. So, you will be much more familiar, and after that if you go ahead and revise this, probably you will be able to understand things much better. So, how do I list the conversations and flows? Okay, straightforward, we can use T-Shark, and then what we do is using T-Shark we just get the conversations that are based on TCP from the evidence file that we can get. Okay. And once you do that, you get something like this. Okay, it says what is the number of frames and from which connection. So, if you look at this, this tells you that there is a secure socket connection that has happened here. So, because the port number is 423, then this tells you that there has been a web connection that has happened. okay, between these two machines and so on. So, looking at the port numbers, you will be able to identify that there are a bunch of these conversations that are happened. One conversation has happened via the web to a web server, there is another conversation that happened via a web server, then there are 3 conversations that happened via 443, which is SSH. So, in this way, and port number 22. So, in this way you will be able to there is something specific about port number 22, okay. So, just take a look at it, okay. So, in this way we will be able to identify the various conversations and flows that have happened. Then once we identify, so what are the flows of interest? For example, I want to identify what this person has done after going to the web server. So, this is HTTP 80. So, I can now take a look at the IP and the port number, and then I try to identify what this person has done this. So, if you use this PCAP cat tool, then you will be able to dump all the data that has happened, that has got transferred between these two ports and these two machines. Once I dump the data, okay, so if you look at Wireshark, you can use the follow TCP stream. If you are, you can use TCP flow also to get all these data. Anyway, stick to one specific tool for the time being, and if you find that that tool is not providing you the necessary features, then move to some other tool. Otherwise there will be using too much of tools and then not much of data we can evince from any of these tools, okay. Then once I dump the particular data, what I will go and do is, now here comes the difficult part, because sometimes you might get incomplete data, okay, and you might have to make out evidences based on this incomplete data. So, what we usually do is, you will actually open a hex editor, okay. So, to manipulate the bits and bytes. For example, you see this JPEG, okay, always begins with 0xFFD8, which is called the signature, and ends with 0xFFD9. So, sometimes it may happen that you may not get the 0xFFD9, then you might have to insert it at some place and see whether the image makes some logical sense, So, you might have to insert this 0xFF at different places and see whether the image makes any logical sense. Those kind of manipulations have to be done, and that can be done with one of the hex editors. The other thing, and you might have to know what are all the signatures. For example, the PDF files carries a particular signature, and this is one of the things that is used. For example, there is a command called file in Linux, okay. It tells you what type of file it is. Now, it actually does this by looking into the signature of the header and then trying to tell what type of file it is. So, it is similar, the same strategy is used here. Only thing is that the data could be live. So, what we do is, for docx, okay, it is 0x504b, and there are many times where I know the beginning, and if I know the size of the file, then I might add up these two and then try to see what is the size of the file. The other thing that will be very useful is if I can get the hashes, okay. So, for example, MD5 or SHA or whatever it is, and then it will be easy for me to verify. Say for example, tomorrow I recreate a file, okay, and then if I can match the hashes, it is a difficult task, but I am just telling you that these are all some possibilities. If I can match the hash, then I have at least a good guess that this is exactly the file that got transferred. So, in that way we will be able to identify, okay, how to get the data out of these kind of bytes, okay. So, finally, okay, so there are, for example, you can also do automatic file carving. So, TCP extract helps you in automatic file carving. For example, in this case you see that there is a zip file. So, what TCP extract tries to do is, it tries to take this 179, the data that is transferred between these two ports, and then tries to recreate the zip file in this way, and then finally you can put all these zip files together and then try to recreate the original file. You may not get the whole file, but at least a partial file will also be good enough as a forensic analysis tool. The next part is the higher level traffic analysis. Now, in this case you have a lot of tools that are available. Now, higher level traffic analysis tools at one hand have the protocols. So, what higher level analysis tools will do is, okay, so this is the tool. So, you have the standard which will be the input, okay. So, this is the standard is the input, then you have your file, okay, the conversation file, So, it tries to find out whether this file follows this standard conversation. So, it is a kind of, for example, suppose the standard says that for every request I have to get a response message. Okay. So, what this tool will do is it will see whether I have got a request packet, then for this whether it has got a response packet. So, in that way it is a sort of a comparison that happens between what is the standard and what is there in the tool. So, in this way you can actually compare HTTP, you can do simple mail transfer. So, simple mail transfer exactly the protocol is actually text based. So, it will be able to do it. So, domain name system, because we know how do you for example, there is a NS lookup. Okay. So, there is a command called NS lookup which tries to identify given a domain name what is its IP address, or the reverse, given the IP address what is the domain name, and then this dynamic host configuration protocol which tries to listen to or try to lease an IP address. So, let us look at HTTP. For example, this RFC 2616, it defines method for get, put, post, head, delete, trace, etc. Now, the point is, if you remember in one of the sessions we did a telnet, okay, and then we did it to port 80, okay. So, IP address port 80, and then we sent this command called get 1.1. So, HTTP actually has this kind of text messages that get transferred, okay, and this is defined by this RFC 2616. So, what we could do is we could search for these kind of text messages and then try to see what is the response that we are getting, and then put these sequences together. And the HTTP tools, there are a lot of tools for doing the HTTP. If you go to Kali Linux, it gives you the tools which can put all these flows together. The next is DHCP. So, DHCP, if you look at this, the client actually sends information to whoever is the DHCP server. So, if you remember, if you use configure DHCP server, okay. So, what happens is that it tries to do who are all the DHCP servers that are available on the net, and then one of the servers will try to offer the IP address, then this guy contacts, requests this person, and then this guy acts it, and then after the client uses the IP address, it just releases. So, this is a standard protocol that is defined by the RFC. So, when I do a flow trace, I just take these relevant packets, okay, and then see whether this protocol is getting satisfied. If this protocol is getting satisfied, then I can go into the details of each one of this, the client address or IP address, who is the server, etc., and then identify the complete conversation that has happened between these two people. Okay. So, this you first do a protocol analysis, and then I do a packet analysis. I mean, and this could be then if I do not get this packet. So, you see this. So, just a brief introduction to what it is. So, if you look at this, this is divided into 4 bytes. So, 32 bits, and this is for the first 8 bits tells you the opcode, the second 8 bits tells you the hash type, okay, and the header type, the header length, and then the number of hops, etc. So, similarly, so this is one word, 32 bits. So, this is the second word, third word, fourth word. So, in this protocol, the fourth word carries the client's IP address, and then the fifth word gives the client's assigned what is the IP address that is assigned, and so on. So, in this case, so remember you need header length, and because these options are variable length. So, using this information I will be able to identify what are all the variable length options that are passed through. So, in this way I can first do a protocol analysis, and then I go ahead and do a packet analysis and try to identify what has happened. Okay. Then for SMTP also there are some important vocabulary that we will use. One is the mail user agent, and then mail submission agent. Now, actually these are formal terms that are used in the RFCs. Okay. So, essentially if you look at the operation basic commands, look at this: hello, mail, received, and then data. So, now this is actually transferred in text format. Okay. So, if I get these 4 keywords, okay, in this protocol, so I will be able to identify. So, if I get these 4 keywords, then I will be able to identify what is the exchange that has happened between my client, mail client, and the mail server. So, formally to say mail user agent and the mail exchange servers. Okay. So, in this way I will be able to identify what is the protocol, higher level protocol that has worked out, and how we can extract information from each of the packets that are there in the higher level. A similar stuff can be done with DNS. Okay. So, in this case what we are trying to do is we are trying to identify the IP address of a particular machine, like say www.google.com. Okay. So, Google, this is a DNS address, okay, domain name system. Okay. So, in this case what we do is we send via UDP packet to port number 53, okay, to any DNS server, and then the DNS server actually sends you the, it follows different types of records. If you go into the record into the protocol, it talks about AA record, AAA record and so on, and then it sends a response. So, if you remember, this actually it forms a hierarchical kind of system. So, if one server does not have its the answer for a particular query, DNS query, then it passes on to the top of its hierarchy and so on. Okay. Now, there are tools like SMTP Dump. Okay. So, these tools actually, if you look at this, they can actually dump whatever is the SMTP messages that are there. Okay. So, here is another tool called offcat. Okay. So, this tool can actually it takes the reassembled single flow of transport layer payload, okay, like TCP flow or PCAPCAT, and protocol summary of all OFT activity on any required files that are transferred. Okay. So, it can do all these kind of now some of these tools you might have to write, okay, some of these tools are already existing. For example, SMTP Dump is there with Kali Linux. So, you should be able to make use of these tools to do some analysis. So, there are certain rules. I mean, if this is a very interesting website called forensicscontext.com, actually they dump some PCAP files and then ask you to do some kind of forensic analysis. You would suggest that you participate in some of these activities. I mean, this is one such, we are not advertising this website, but it is one such website where we can go ahead and work on their problems, because by solving some of these problems actually, I mean, you can even write your own software, okay, to do some forensic analysis. So, here is one that is written by this person. Okay. So, if you look at this, you input a PCAP file and then output is authenticated data, credential, mail header info, attachment, MD5 sum, and then it produces a report. Similarly, network miner can also be used. Okay. So, the advantage of higher layer techniques is that you will have to write some small specialized tools, and since it is higher level protocol analysis, it is actually easy to, I mean, not easy, I would say it is a interesting work to do this kind of analyzers. Okay. And these can be very successful only if you have an idea of what the packet contains. So, as we discussed earlier, some protocols are not open, therefore, you might have to identify what the protocol is and then write these kinds of tools. That makes it very challenging. Okay. And so, these are, you could also write a kind of multi-purpose tools. Okay. So, for example, a network miner is one tool which actually gets a lot of information, similar to say Wireshark also gives you a lot of information anyway. So, you should be able to write these kind of higher level protocol tools that will help you do forensics much faster. Okay. So, this is a good reference book which we have been using for this course, and what we will do in the next section is, okay, fine, we have talked a lot about flow analysis, we have talked about lot about protocol analysis, we have talked a lot about packet analysis. What we will do in the next session is that we will go ahead and get one evidence file and then work through this whole process and see what is the problem. It is a kind of a case study, what is the problem that was reported and how one is able to identify and solve a problem. Okay. Thank you very much.